Welcome to qnawire.
So this question wants us to find the speed of the proton that has a total energy of 1,000 GeV. And then it wants us to find the speed. And second, it wants us to find the angular frequency omega of a proton that has this speed. And we want to use the relativistic equation and the non-relativistic equation. So let's first look at the first question. So in order to find E, we have to use this equation. E equals omega times mc squared. And it is related to speed. And it's at rest. Rest mass, when it starts to move, it carries not only a rest mass but also a kinetic energy. Total energy is 1,000 eV. So with this expression, we will be able to find what omega is. Let's first find out what omega. From omega, we can find this. So omega equals E over mc squared, and we know it's 1,000 eV, and there is just the rest energy with 900.0 eV. This gives us a of 1065.8, and then we can find the v from this omega, because omega equals 1 over square root 1 minus v squared over c squared. And we need a for this, and turns out that v is very large, 0.999999. There we have 69559 times. So it is very speed of light. And then for the second part, we want to find the angular frequency. So the angular frequency is by charge, magnetic field, mass, omega. So non-relativistic case is equals 1. The angular frequency is EB over m. Here, E is the charge, B is the magnetic field, which we are told is 4 Tesla, and then m is the mass of this proton. So the non-relativistic case, we want answer of 3.83 times 10 to the base rate per second. And what about the relativistic case? The relativistic case is that we need to consider this, and we do not assume it to be. So if we add omega, which we already found out, 10.5.8, we will get a slightly smaller angular frequency of 3.59 times 10 to the 5th